Hello, I'm Rodrigo Tapia. I'm a researcher in the Freight and Logistics Lab at TU Delft. I hold a PhD from the Federal University of Rio Grande do Sul in Brazil, where I did my thesis on behavioral analysis of regional freight transport, where I use mainly tools from choice model. I also have experience as a researcher in the Institute of Transport Studies from the University of Leeds and in the Ministry of Transport of Argentina. Currently, I am working in the LEAD project, where we aim to develop digital twins for urban freight transport. In this video, we will see the basic concepts around digital twins and how can we apply it in the city context and particularly in the urban freight context. What are digital twins then? Digital twins is a representation or a digital copy from a real-world system. The concept has been brought mainly from mechanical applications, where they wanted to represent a machine in the digital world, but it has been loosened up then to have applications in the production environment, that is in industry, and now it has been made broader in order to incorporate logistics and cities in particular. It has two main components. The first component is the physical entity, the system that we want to model, we want to reproduce digitally. The second entity is the digital twin, where we have the representations, the models, and their interactions. Both are connected through measurements, that is, the inputs that the physical world gives towards the digital twin, and also the digital twin can affect the physical entity through a decision maker, being them a human, in particular, for example, an urban planner, or could be an automatic decision system in the case of machinery. What is the value of digital twins? Why do people want to use it? First of all, it gives a descriptive value. It gives you the possibility of know what is the state, what is the status of the physical entity at any given point in time. It can also provide analytical value. That is, it allows you to simulate scenarios and provide inputs and insights that otherwise cannot be measurable directly in the physical entity. It can also provide diagnosis of problems that are difficult to analyze if you purely see the physical twin. Finally, it has predictive value. It can forecast and can give the future status of the physical twin. But how do these concepts that are so linked to machinery, so linked to hardware in the high frequency, can be used in cities? Currently, the main uses for digital twins are for representation purposes, that is to model the hardware, the buildings, the road system, the sewer system, and have it mapped in order for the analyst to track how it's going on and what is happening. However, for transport in particularly, it's important that we know that cities have different cycles, different frequencies. What do I mean by this? That there are different planning scales and different type of actions that we want to represent. For example, we have low frequency digital twins for strategic planning, that is for long cycles. For example, a new highway, a new road, the effect on the physical entity will be in years, months. Also, we have a mid-frequency for tactical planning, that is, you can have an interruption of a road because of a new building, and you want to represent that, you want to know what's happening. That means that you have to consider that frequency and that cycles in your models. Or you want high frequency for operational, that you want to see minute to minute, hour to hour, what is happening. You want to absorb it, you want to digest it to your model so you can know what is happening at present status. For urban logistics, naturally happens the same. So it's important that the frequency of the physical twin has to be compatible with the frequency of the models of digital twin. The digital twin, as we said earlier, is a representation, it's a model, and it's as strong as the assumptions that we have in each of the models. So if you want to represent a longer scale, a lower frequency, then you must have models that are able to be in sync with those processes. How can you use a digital twin for urban logistics? Well, you have to have the different models and different representations for the different types of decisions and problems that urban logistics face. In the LEAD project, that it's an acronym from Low Emission Adaptive Last Mile Logistics Supporting On-Demand Economy through Digital Twins, we divided our frequencies in the three that we said before: strategic level, tactical level, and operational level. For each of these levels, we have different type of models that can cope with those decisions. For example, for the strategic level, we can use demand models, for example, population synthesis, that can cope with long-term and macro changes in society, or have some graph optimizations to give strategic inputs on, for example, where to have a warehouse. And you can have network models where you simulate the impact in the network. For the tactical level, you can also use agent-based models besides the ones that we mentioned before. In an operational high-frequency level, other models might be useful as well, and others stop being as useful. For example, demand models where you simulate the demand might not be as responsive as is needed for the necessities for representing high-frequency changes. Also, it is important to have impact assessment measure models in order to represent and give the results of the models in a way that the analyst can make decisions on. In our project, we use a model-centric approach, that is, we base and we give a lot of importance from the models, because the models gives the strength and the weaknesses of our representation. These models, as we said before, can be from any type, can be theory-driven, data-driven, could be artificial intelligence-based, or traditional statistic models. That is not relatively important. And it is, yes, very important to have a strong connection with the data ingestion, that is the process of the data that comes as an input and you can use to make sure that the digital twin is a representation of your physical entity.